Here's a model of a molecule, a xenon tetrafluoride, an exotic molecule that has a mostly planar structure. Gotten data from an article in the literature back in the 60s. And we're simulating vibration modes at about 2000 Kelvin. I'll press play. You can see in the animation these bond angle modes are much softer, have much more physical lateral motion than the longitudinal modes of the xenon-fluorine bonds. Of course, the fluorine molecules, fluorine atoms, move a lot more from their original positions than the xenon atoms, simply because they're lighter. But you can see how there are restoring forces both in the radial direction and the azimuthal direction. I've chosen a temperature here where make sure that there are several quantum levels populated so that you can use a classical model and get some kind of meaningful results. Let's look at some plots. This is all to scale, so all of the physical variables have meaningful values. If I plot one of the xenon fluoride bonds versus time, we're actually going to get a readout in femtoseconds here. We have maybe 4 oscillations in 200 femtoseconds. Yeah, 200 femtoseconds. And the other, that's the radial direction, about 2 angstroms. Oscillation around an equilibrium position of about 2 angstroms. I can look at another xenon fluoride bond, and we see slightly different results. They don't behave exactly the same way, but they're kind of similar. Then the fluorine forces that impose the bond angle torques, though, have a much longer frequency. You can see the high frequency stuff imposed on them, but they have a much longer time because of their much smaller restoring force. And so that's you're looking at more than almost 300 femtoseconds for a full cycle for that force. So you've got then you can translate those into infrared frequencies and so forth. And this can also be modified. For example, I can remove components and go ahead and run the simulation. The physical results may not be meaningful, but you can build up the model using the GUI. Is the point that's interesting. All right, thanks for watching.